On reading this question, we find that it asks us to draw 3D structures of PCl3 and PCl5 and name the orbital hybridization of the central atom in each case. Then we need to determine which molecule has a dipole moment and which does not. Whenever you're asked about the shape or the hybridization of a molecule, it's a good idea to draw a Lewis structure, so that will be the first step in our plan. Once we have the Lewis structure, including all lone pairs, we can count the number of electron domains and determine the 3D structure of the molecule and its hybridization. Remember, to draw in 3D on a 2D piece of paper requires you to follow some conventions. Bonds coming out of the page are drawn as wedges, and those going into the page are dashed. Finally, using the 3D structure as a guide, we can draw all the individual bond dipole vectors and add them up to determine the overall dipole moment for each molecule. Okay, now solve the problem. PCl3 has 3 chlorine atoms, each with 7 electrons, and 1 phosphorus atom with 5 electrons, for a total of 26 valence electrons. From the periodic table, we know that the phosphorus atom is least electronegative, so it will be the central atom. And 26 valence electrons allows us to give each atom an octet. This structure has 3 bonding electron domains and 1 non-bonding electron domain, for a total of 4. 4 electron domains means a tetrahedral electron domain geometry, and sp3 hybridization around the central atom. For PCl5, there are 5 chlorine atoms with 7 electrons each, and 1 phosphorus atom with 5 electrons, for a total of 40 electrons. By connecting all the chlorine atoms to the central phosphorus atom, and placing the remaining 30 electrons as lone pairs around the chlorine atoms, we get a Lewis structure that looks something like this. It has 5 bonding electron domains, which means a trigonal bipyramidal geometry, and an sp3d hybridized central atom. Now we can consider the dipole moments of each molecule. Since phosphorus is less electronegative than chlorine, all the dipole arrows for both molecules will point away from the center. For PCl3, the arrows all point away from each other and slightly down, giving an overall dipole moment that points straight down. For PCl5, all the arrows point away from the center in different directions. Upon closer examination, you should notice that the axial arrows cancel each other out, and the equatorial arrows cancel each other out, leaving a net dipole moment of 0. Now check your work. We've drawn a 3D structure for both molecules and named the orbital hybridization of the phosphorus atom in each case, and we've determined that PCl3 is the molecule with the non-zero dipole moment. All that's left to do is circle it and write a short explanation. PCl5 is symmetrical, so its individual bond dipole moments cancel out. This is not true of PCl3.